Okay, so here we are for the second part of 10.6, just another set of lectures. I've noticed that some of the early assignments being turned in, the first part looks really good, and then the second part, a lot of wrong answers. So it's because I never went over length. So I'm going to do that right now. I'll go over how to find the length of an arc today. That's our main thing. And so hopefully I'll try to make this a really quick video. It's not that bad because really all you're using is just a proportion. And we remember how to do portions, right? It's just two equal fractions. So we're going to have one fraction equal another fraction, and then you're going to cross multiply to help solve for the one unknown. You'll know three of these, and then given that, you can solve for the one unknown using algebra, remember? So we're going to do a couple of examples really fast about how to use this. Keeping in mind that the central angle equals the arc measure. We went over that in the first lesson. Hopefully you saw that video today, or yeah, Monday. So basically, let's look at an example of finding length. So if you can remember, central angle equals arc measure. So if you look at this proportion, it's arc measure or central angle. It could be either one, depends on what they give you. That'll go onto the top part of this fraction out of 360. Notice that if you have a central angle, it's part of the whole circle. Part is to the whole thing, and length is just part of the circumference. Recall that the circumference is the distance all the way around. So a length would just be part of the whole distance around. So part is to whole as part is to whole. Be consistent. B-E consistent. I know you missed me saying that. So part is to the whole thing as part is to the whole thing. You set up a proportion, you cross multiply. If you need to, sometimes you remember you can do it in your head, but if you cross multiply, it's always going to be safe. You'll always get it right, and that's what you're going to do. So let's do an example of this. So let's say, and we'll start off with an easy one. So let's say I have a central angle here, and again, I like the right angles. They're easy to see, they're easy to comprehend. So let's say I have a central angle that's 90 degrees. So of course that's the same as the arc measurement. So central angle, arc measurement, one and the same. Remember, they're the same thing. So now that we've got this, we now have in our first example, example 1, 90 is to 360. Now, does that make sense? That's 1/4. This is 1/4 of the circle, right? So we'll do that in a second, but that's just going to be basically 1/4. Now, if you recall from the first lecture, the circumference is just the diameter times pi. So we're going to need some information here, right? So let's say that the radius, just to keep it easy, let's say the length of the radius is 5. Well, then wouldn't that make the diameter, if you were to continue that, a grand total of 10? Because the diameter would go all the way across. So the diameter is going to be 10, so 10 times pi is going to be this value. So on the bottom part of this proportion, it'll be 10 pi. Remember, we're going to solve for the arc length. So I'm just going to put L for length. So all we have to do is solve for the one unknown. And again, we can reduce this problem and make it easy. So what we're solving for is the actual distance from here to here while staying on the circle. So for all you people that are running track, or if you ever had to run around the track outside, it'd be like running in this lane, if you will. How far would you have to run from this part all the way to here while staying on the circle? That is the actual length. Measure refers to degrees, length refers to distance. So the length is part of the whole circumference. So I'm just going to call this 1/4, if that's okay with everybody, just to keep the number small. L over 10 pi. And then now all you have to do is just cross multiply. Basically, aren't we just going to basically say 4L equals 10 pi? So 10 divided by 4. Or I'll go ahead and write that out, I guess. I don't want to assume too much here. So we have 4L equals 10 pi, because 1 times 10 pi is 10 pi, divided by 4. So L is just going to be 2.5 pi. And lots of times, even on that worksheet, it'll say leave your answers in terms of pi. So that's all you have to put, in terms of pi. Now, if they want you to round to the nearest tenth or hundredth, then you'll have to take 3.14 times 2.5. No big deal. Okay? So there's an easy one. Let's try one that isn't as easy. So we'll use the same radius. So the radius will be 5 again, no big deal. It means your diameter will be 10 again, no big deal. Let's see. Let's try let's try an angle here, the central angle here. Okay, so let's go ahead and say that the arc measure from A all the way to B, from A to B, let's say that arc measure is 120. So 120 degrees. So again, is an arc measure the same as the central angle? And that's just your numerator here. Okay, so it's 120 out of 360. So again, if you are familiar with this, isn't that just going to be basically 1/3? It's 1 out of 3, right? 120, 240, 360. But again, let's write it out. We'll reduce it over here later, okay? So then now, if I want to find the length of AB, how far is that distance if you stay on the circle? So we'll call that L again. And then again, it's a radius of 5, so our diameter is still going to be 10 pi. Because it's the diameter times pi, not the radius, the diameter. Remember, the diameter is 10. So 10 pi. So now, if we reduce this just to make our life easier, this is basically just 1/3. And then L over 10 pi. I'm just going to leave that alone. And then cross multiplying gets a lot easier for us. So I'm going to write it out. So 3L equals, of course, 1 times 10 pi is 10 pi, divided by 3. So now we have, you can call it 10 over 3 pi, or you can even, if you just want to, if you like the decimal thing, but this is the best answer. This is what you're going to see a lot next year. Right here, you're going to see a lot of improper fractions with pi. Okay, or actually when you go to pre-cal, you'll see that a lot. But you can leave it like that. That's cool with me. It's just 3 1/3. I don't like mixed numbers with pi, but you can do it if you like. Or if you're just so desperate you have to have a decimal, you can put a bar over the 3 because that's just basically 1/3. So you could do it this way as well. But there is nothing wrong with this answer. This answer is very good, in fact. That's exact. This one's not bad either. Okay? So, hopefully this makes a lot of sense. Maybe I could do one more really fast. I wasn't planning on it, but I'll go ahead and do it really quick. So let me flip it over real fast. We'll use this circle right here, the back of that, of course. So now, let's say that the radius now is 10 instead of 5. Let's say that we have an angle here. So we have A. Let's say we have an angle that comes across here. We'll call that the right angle again. Here we'll call this B and C. So let's find the length. So let's find the length of arc ABC. Now remember, the directions being everything. You start at A, you go through B to get to C. So if I tell you this angle right here is 110 degrees, then wouldn't the arc measure just be 90 plus 110 for a grand total of 200, right? 90 plus 110 for a grand total of 200 degrees right here. So 200 is out of 360, part is to the whole, as length would be to the entire circumference. So if the radius is 10, then we know the diameter better be 20, right? The diameter times pi. So 20 pi. There we go. So again, I'm going to reduce just to make my life easier. So I'm going to go ahead and it's just basically 20 over 36, so 10 over 18, so 5 over 9, right? So 5 over 9. So 5 over 9 equals L over 20 pi. Remember, I just reduced. If you times that by 40, you get 200. Times that by 40, you get 360. Okay? Reducing, so now we cross multiply. So now we're going to get 9